In this video, you'll learn about two-way frequency tables. Essentially, a two-way frequency table is a table that provides the frequency for two variables. So for example, the two variables we have here is whether you're male or female and what type of car you drive, whether it's an SUV or a sports car. Now, looking at these two-way frequency tables, we have to deal with a couple of different things. One thing that we have to deal with is the totals for the rows. So if we look over here, we can see that we add across to give our row totals. So this 60 is the male total, which is given by adding the 21 plus 39 equals 60. Then for the next row, I can add the 35 and 45 equals the total. So this is the female total. Now for the columns, we can do the same thing, adding vertically. So if I add the 21 and 135 together, gives me this, which is the SUV total, which is one of our columns totals. And I also can add the 39 and 45 together, which gives us our sports car total. Lastly, the final number that we have to consider here is the total of the entire chart, which is shown in the bottom right corner. Now this 240 can be either achieved by adding the 84 and the 156 across, or we can add down the column, but this is, which would give us 240 either way, but this is the total of the chart. Now, if we were to read without having all of the assistants labeled on there for us, the total number of SUVs, so if I go to the SUV column and I go straight down, I can see that 156 is in the total for the SUV category. So you can fill in the total number of SUVs is 156. Then for the total number of sports car, if I go to the sports car column and go to the totals, I have 84. This gives me 84. For the total number of males, if I go to the males row and I go to the totals column or add straight across, it gives me 60. So the total number of males is 60. For females, if I go to the row for females and go straight across, I have 180. So the total is 180. Lastly, the total of all of them is always this bottom right number, which in this case is 240. And that's the total for the entire table. Now, if we want to identify specific values, for example, if I wanted to identify the number of males with SUVs, I would have to look and say, okay, here's the males column or the males row and the SUV column, which meet at this one number. So this means the number of males with SUVs is 21. The next one asks for the number of males with sports cars. So if I go for males, it is in this across row, and sports cars is in the second column. So you'd have to go over to give us this number of 39. Now, if it asks for the number of females with SUVs, for example, I have females is in the second row and SUVs is the first column. And those two would meet at the 135. So the number of females with SUVs is 135. And lastly, if it asks for the number of females with sports cars, the females is in the second row and sports cars is the second column. So I can go down for sports cars and over to meet in this corner. So the number of females with sports cars is 45. Now you wouldn't necessarily need to add in all these arrows, but this is just to help you with seeing where the numbers are coming from. Now, in order to determine the probability of an event, the probability of an event is the number of successful trials over the total number of trials. And in the case of what we're doing today, you're always going to leave your answer as a fraction and make sure you simplify it so it's a fraction in simplest form. These first examples refer to the probability of a random selection, which means that we are selecting, so your probability is the number of successes over the total of the table, which in this case, the total of the table is 240. So our probabilities, when you're dealing with a random selection, it's always going to be some sort of number over 240. Now, if I look at the first one, says, what is the probability that a randomly selected individual is a male with a sports car? So if I'm looking for male with a sports car is at 39. So I can put it's over 39. And then my fraction, again, because it's the randomly selected, this means that it's going to be over 240. Now, if we check to see if it simplifies, we can further simplify this by dividing the top and bottom by 3, and this would give us 13 over 80. Now, the next problem says, what is the probability a randomly selected individual owns an SUV? Now, this doesn't specify whether they're male or female, it's just whether they own an SUV. So this means that they're referring to the SUV total. So if I'm looking for the SUV total, I'm looking for the number 156 at the bottom. So it'll be 156 over, again, it's the probability of a randomly selected, which means that I'm putting it over 240. Now, if I want to simplify 156 divided by 240, I can check my calculator. And if I divide the top and bottom by 12 to simplify the fraction, it gives you 13 over 20. For the last example, it asks, what is the probability a randomly selected individual is female? Which means that they're not necessarily looking for the car type, so it's they're looking for the female total, which from looking at the table is 180. So I'd have 180 over, again, remember it's the randomly selected, which means I'm putting it over 240. So if I simplify 180 divided by 240, you can divide the top and bottom by 60 to give you 3 over 4. Now you may not necessarily simplify every example, but if you do, you need to make sure the fraction is in simplest form. Now in our last types of examples, it asks for the probability from a given group, which means that when we're dealing with the probability from a given group, it's going to be the number of successes over the total number of individuals in that group. So, for example, in the first part, it says, given the individual is male, So the given group is the male total. So I'm going to put the number of males on the bottom, which looking at my diagram, the number of males total is 60. So I can put 60 on the bottom. It says, given that they're male, what is the probability they own an SUV? So now, since we're already given that they're male, this means we want someone that's male and has an SUV. So if I'm looking at male and SUV, that gives me the number 21. So I can put this as 21 over 60. Now, if I simplify the 21 over 60, it gives you a value of 7 over 20, which is your final answer. Now, the next example, we erase what's on our table to clear it off again. It says, given that the individual owns a sports car, that means it's asking us for the sport car total. And if we look at the sport car column, sports car total is 84. So it's over 84. It says, what is the probability that they are female? So this is asking for the number that are female and have a sports car, because it has to satisfy this first condition on top of what's given. So if I look at the sports car group, sports car and female is this number 45. So I get 45 over 84, which when you simplify becomes 15 over 28. In the last example, it says given the individual is female, so it's asking for the female total, which if I erase what's on my table, my female total is 180. So I can put this over 180. It says, what is the probability they own a sports car? So it's asking for the number that are female and own a sports car, which given looking at the table, a female and sports car is 45. So if I simplify the 45 over 180, it gives me a value of 1 over 4.